So the last section we're going to look at this week is 2.6, and it kind of goes back to something we did before. In the warm-up, we talked about solving equations with absolute value. Okay, and we went through it and saw that you had to split it into two problems after the absolute value was by itself. Well, this is going to be almost the exact same thing. All right, so I'm just going to skip over that part. So let's go right to the guided notes. So on your guided notes, you're going to have some steps. There's 3 steps. And the first step to solving an absolute value inequality is to make sure the absolute value bars are by themselves. So how do you make sure they're by themselves? Well, use the opposite operation to move anything you need to, okay, to move stuff to the other side. Here's an example of something where you would have to do step 1. 2 times the absolute value of something is less than 10. It doesn't even matter what's in these bars. You'd have to move this 2 to the other side first. Does anybody remember in the warm-up? How did we move the 2 to the other side? Yep. Right, you'd have to divide each side by 2. Now, what if you had something like this? 3 plus the absolute value of, doesn't even matter, just absolute value, equals 5. This time you have absolute value bars, but you have a plus 3 in front of it. How do you think, and this would be an inequality, how do you think you would move this 3 to the other side? This time you wouldn't divide by 3.
Minus 3.
You'd minus 3. And then you'd have just the bars on the left, and there'd be something inside them. But the 3 would go to the other side. Right? So we just use the opposite operation to move anything that's outside the bars to the other side. You won't always have to do that. Here's a problem. We're not doing it yet. But there's a problem where the bars are already by themselves. There's nothing you have to do to get them by themselves first. Yes? Yes. So the 2 things that you might have to do to get something by itself is either addition or subtraction. Like in the case where it says 3 plus, you have to do subtraction. Or the other thing you might have to do is multiplication or division. So in the problem where it says 2 times something, we had to divide by 2. Most likely, you're only going to have to do one of those things per problem. You're not going to have to do both adding and subtracting and multiplying and dividing. So that's step 1. Again, reminder, you might not always have to do step 1. That might already be done for you. So step 2, we're going to split it and flip it. Split and flip. All right, so hopefully maybe you can remember it that way. Split and flip. Those are the 2 things we have to do. So the split part, you guys saw that in the warm-up. We split it into 2 problems. The flip part, well, that's a little bit new. We didn't have inequalities in the warm-up. We had equal signs. And now we have inequalities. So part of the problem is going to involve flipping the inequality. So you're going to see one of those 4 signs. Okay, you guys already have those printed on your notes. It's either going to be a less than, greater than, less than or equal to, greater than or equal to. Okay, it'll be one of those 4. The first problem that you split it into, again, you always write these without the bars. So the bars are going to be taken away the second you split it. And the first one is just the original problem. Just take away the bars. So that's just like it was with an equation. It's the same as the original without the bars. Now, does anybody remember for the second one, what did we do to the number on the other side? Yep. Right, we made it negative. We still have to make it negative, but we also have to flip it. That's the extra step. So for the second one, you still make the number after the sign the opposite, just like you guys did before. Make it the opposite. If it's a positive, make it a negative. If it's a negative, make it a positive. But the extra step is the flip. You have to flip the sign to make the second one. So once you do step 2, you're going to have 2 separate problems to solve. And the third step is then to graph it, okay, on the number line. Now, the graphs we're going to do today are going to look just like the ones we did yesterday. You're either going to have 2 dots, and you're going to connect the dots, right? Go between them. Or you're going to have 2 dots, and you're going to end up shading in opposite directions. Does anybody remember what kind of problem or what word was in the problem when you went in opposite directions? Yep, that was an or. And what word would be in a problem like that? Yep, that'd be an and. So it's always going to be one of these 2 things. So how do we figure it out? Now, how do we figure out if we should use the word and or the word or? Well, it all depends on this. Again, we're not doing this yet. I'm just showing you. This symbol, because it's pointing to the right, tells me if it's an and or an or. That's what you look at. If the original sign is pointing to the left, remember, if it's pointing to the left, it's a less than. Left is less than. Pointing to the left means this is going to be an and problem. And the hint, if you try and pronounce it this way, instead of saying less than, pronounce it like less than. It almost sounds the same. Less than. And less than is an and. Less than. So less than is an and. What do you think greater is? Or my hint is, what do you think greater is going to be? Yeah? Or. Think if you pronounce it that way, instead of saying greater, say greater. Greater. It's greater than. Greater is an or. Greater or. So that's the hint and how you can remember that one. So if the original problem has a greater symbol, it's an or. If it has a less than, it's an and. Okay, all the rules that we had before still apply. If you multiply or divide by a negative, you still flip the sign. So we might end up flipping the sign a couple times here. You always have to flip it when you split it. That's one time you might flip. Then, if you divide by a negative at any point, you might have to flip it back. Okay, so it is possible to flip it more than once. Okay, and you guys have You have that already printed on your guided notes? Okay, so you got that. So the only thing you had to fill in here was the hint in the parentheses, and then the blank line right before it with the word and or. Okay. Anybody need anything else from there? All right, I think that was it for this page. Yep. All right, so let's try this. So you've got some room right at the bottom. It says solve and graph. So its absolute value of 5 minus 3x is greater than or equal to 9. All right, so Michael, what is step 1? That's step 2. There's something we have to check first for step 1. What did we just write down on our notes for step 1? That might be something you would have to do to get this, but what's the goal in step 1? You want to make sure that what's going on. You might have to add or subtract to do this. You might have to multiply or divide, but just make sure what. Yep.
Get your absolute value bars by themselves.
Yeah, just make sure the absolute value bars are alone on one side, and that there's nothing else outside of them. All right, so when we look at this one, Sean, are my absolute value bars by themselves on one side? Yes. There's nothing else out here like that. Okay, so the absolute value bars are by themselves. So now we can go right to step 2, which is to split. Okay. Anyone think they can tell me the first problem that this is going to split into? Yeah? Perfect. So 5 minus 3x is greater than or equal to 9. We'll come back and solve that in a minute. I need my second one. Anyone think they know what the second one is? Great.
5 minus 3x is greater than or equal to negative 9.
Okay, so I like that you got rid of the bars. I like that you made this number negative. But what's going to go in the spot that I left blank? Yeah? This is a greater than or equal to on the left. We want a less than or equal to. So we split it and flip it. The bars are always gone, so we don't have to worry about that. Always get rid of the bars. But for the second one, split and flip it. Now we need to put a word between them. This is either going to be an and or it's going to be an or. And it makes a big difference when we go to graph. So Caleb, is this an and or an or?
This would be a or.
How come?
Because it's a negative and it's going to get switched. Wait.
Anyone else have a thought if this is an and or an or? Alex?
It's an or.
Okay, how come?
It's an or.
Not sure?
No, I'm sure, but it's not.
Right. Someone else tell? Yeah, Dorian?
It is an or.
Okay, why?
Because the original sign is greater than.
Right, the original sign is a greater. It's a greater symbol. Greater than is always an or problem. So when we're done, we should expect to have two arrows going in opposite directions. All right, so that's the only part that was new. Now from here, it's what we learned earlier in the week. Solve each one of those inequalities. How about, let's see, Anaya, for the one on the left, what would be my first step?
You would add 5.
Okay. And what's 5 plus 5?
Cancels out. Oh,
5.
10.
So now we have 10. And what's 9 plus 5?
14.
14. Okay, what would you do now?
Would you minus 10?
At this point, yes, you would have to minus 10. Does anybody see what we should have done originally so we don't have to get to this step? So you had the right number, but yeah? So, yeah. What we really should do at this step is subtract 5. So what ends up happening is now the 5's cancel. So you wanted them to cancel, so we have to use subtraction. So Abby, what's on the left side now?
Negative 3x.
Yep, all we have on the left is the negative 3x. And Emily on the right, 9 minus 5 gives me, how much? 4, yep. Okay, so now we have negative 3x is greater than or equal to 4. And Joe, do I have x by itself yet?
No.
No, what's still there that we don't want there?
Negative 3.
Right, we don't want that negative 3. So how are you going to get rid of the negative 3?
Divide it.
Yep, so we're going to divide. And what are you going to divide by?
Negative 3.
Perfect. We're going to divide by negative 3. Now, we just divided by a negative. So what's going to happen right now? Yep. Right, we have to flip the sign. I like to do that first so I don't forget. So the sign just flipped. And Finnegan, what's on the left side now?
It would be x.
Yeah, it's just x. We got rid of the negative 3. And on the right, you can just leave it as negative 4/3. When you write a negative in a fraction, it doesn't matter if you put it in the top or the bottom. I usually put it in the top, but it's the same if you put it in the bottom. Okay, so there's our first part. X is less than or equal to negative 4/3, or and now let's solve the other one. Sophie, what would be my first step to solve the one on the right? Subtract 5. It's the same first step as the other one. So subtract 5 from both sides. That's gone. And negative 9 minus 5. Abby, what's that going to give me? Yep, negative 14. And Lexi, what would be my last step? And what kind of number did you just divide by? What kind of number did you just divide by? Well, you tell me. What should I do right now? I was trying to give you a hint, but what do you have to do now? Why? Right, we divided by a negative, so we have to flip the sign again. So this one had a lot of times we had to flip it. That's gone. So now on the left we have x, and on the right, negative 14 divided by negative 3. The negatives cancel, but you can just leave it as 14 over 3. Okay. Now, that's the solve part. To graph that, that's a little tough as a fraction. So I'm going to use my calculator, and I want to see what these are as a decimal, because that's going to make it a lot easier to do my number line. So let's take 14 divided by 3 and just write down what that is off to the side. It's a little over 4.5. Okay, so it's about 4.7. Okay, so just so we have an idea of where to go on the number line, we want to go at 4.7. And then negative 4 divided by 3. Let's see, 4 divided by 3. That's about negative 1.3. So those aren't the nicest numbers, and on Edge Elastic, I'm going to try to make it so the number always comes out to like a 0.5, so that's a little easier to find. But let's make our number line. All right, so let's start with the one that's 14 over 3. Can somebody explain to me, where is 14 over 3 on the number line? Yeah?
Kind of between like 4 and 5, close to 5.
Yeah, between 4 and 5, a little bit closer to 5. Good. And what kind of circle would you put on that one?
Close.
Yep, that's going to be a closed circle. So we got a closed circle there. Both of these are set up the way we like it. Letter, symbol, number. So from there, Cadence, which way am I going to shade? So from this dot, which way would I shade? To the... So we're going to shade this way? No, to the right. We're going to shade to the right. So that's our first one. And the second one, Annika, where's negative 4/3? Yeah, it's between -2 and -1. A little bit closer to -1. Okay. So let's put our dot there. This is still going to be a closed circle because it has the equal to. And Sean, which way am I going to shade this time?
To the left.
Yeah, to the left. Okay, it's a little annoying that we have the decimal, but that's how you can always do it if you have to graph it. Just change the fraction to a decimal. And as long as you are roughly in the right area, you're going to get credit for it. Okay. Any question on that? All right, so let me see. Okay, so we've got that one, and I think this last one has a, yeah, okay. Let's do, I'm going to give you guys a second to try 1B. Okay, so see if you can do 1B. Let me just change it a little bit. So see if you can solve 1B. And don't forget about step 1 in this problem. All right, so let's start to look at this one. Okay, first question, is this one ready to split? No? What's wrong with it? Me, I saw you saying no. What do we have to do first? Right. Doesn't even matter what that x minus 5 is right now. Don't even worry about it. Just start by dividing each side by 2. So now we have that on the left. Do I flip the sign when I divide by 2? Yeah.
No.
No, I didn't divide by a negative number, so I'm not flipping the sign. And then I get 14 divided by 2 is 7. Okay, Natalie, am I ready to split it now? Yep, ready to split. Okay, who can tell me one of the problems I'm going to get when I split? Yep.
X minus 5 is greater than 7.
Okay, so x minus 5 is greater than 7. Good. And, yep, Abby. Perfect. So she split it, and she flipped it, and made that other number negative. Now, because we only had an x inside, this one's going to be pretty quick to solve. Just add 5 on both sides. And I get x is greater than 7 plus 5 gives me, how much? Yep, 12. Good. On this one, add 5 on both sides. What's negative 7 plus 5? Yep, negative 2. And there's one thing I'm forgetting. What haven't I written down yet that's part of the answer? Yeah? Yeah, I haven't put down whether it's an and or an or. And I agree with you, this one is an or, because it's greater. All right, let's make our number line. Let's go by 4s. So negative 2. Actually, yeah, let's go by negative 2s. I think that'll be okay. 2, 4, 6, 8, 10, 12. That's good. Okay, what kind of circle on negative 2? Jacinda.
Circle on negative 2 would be open.
Yep, that would be open. Alex, what kind of circle on 12?
Open.
Open. And where do we shade? Between or opposite? Yep.
Opposite.
Opposite. Good. Okay, so we did one where you had to get the absolute value by itself first by dividing. We did one where the absolute value was already by itself and you didn't have to do anything. Let's finish up by doing one where you have to get the absolute value by itself, but this one isn't dividing to get it by itself. So just to start people off here, what is it you have to move to the other side first? Yep. You have to move this 4. And right now it's a plus 4. How would you move plus 4 to the other side? Yep.
We'll just subtract it.
You would subtract it. That's your first step on this one. So let's do the first step together. That's gone. So now you have 2w minus 1 is less than, what's 15 minus 4? Yep, 11. So now you guys take a couple minutes and try to finish that one up, just like the other two. Okay, that's the only step that was a little different this time. So we're at the point where we can split it. Caleb, what was your first inequality?
My first inequality was 2w minus 1 and I left it positive.
And anything else?
Oh, minus 1 less than 11.
Less than 11. Okay. And how about Joe? What was your second inequality?
W minus 1 is less than.
Greater than.
Greater than negative 11.
Yep, good. And now I'll just solve this quickly so you guys can see it. Add 1 to both sides. Divide by 2. W is less than 6. And for the other one, when you add 1 to both sides, negative 11 plus 1 is negative 10. Divide by 2. Notice I'm always dividing by a positive, so I don't need to flip anything. W is greater than negative 5. And what word goes between the two? Yep, this is an and. Because the original symbol was a less than. Let's set up our number line. Let's go by 2s. Again, you're not going to really have to worry about how to number the number line on the test. So I've got an open circle on 6. I've got an open circle on negative 5. And since it's an and, I shade, shade between, connect the dots. Okay, so quick reminder that there is a review guide online. What I think we'll do this week is if you do the review guide, I'll make that extra credit for the test. So you don't have to do this review guide. The only homework you have to do tonight is the worksheet on 2.6. But if you do the review guide that I just had on the board, I'll give you extra credit on this week's test. I'll be after school today if anybody needs extra help or needs to make anything up from last week.